So let's take a look at how to calculate the expected unit short. First though, let's look at the other values that we're going to have to find expected values of. And so I'm going to look at this for two cases. One is where we have a continuous variable for demand, and that could be something like the normal distribution, as well as a discrete case. And this is where I might have my demand only takes discrete values like a Poisson distribution. So I'm always going to have to calculate my expected units demanded. This is my expected amount of demand, or my mean value of the demand distribution. And this is simply going to be, for the discrete case, the summation from x equals 0 to infinity of the value of demand x times the probability that that occurrence happens. We'll call this sometimes x hat. And you can see for the continuous case, it's the same thing. Instead of a summation, I have an integral from 0 to infinity of x times the probability distribution function, fx dx. And again, it's x hat. Now we'll also want to calculate the expected units sold. And we've talked about this before, but it consists of two terms. Right? The first term is when demand is less than my order quantity, and the second term is when the demand is greater than my order quantity. And so two summations, and for the first one, I'm going to sell x, right, the demand, and for the second term, I'm only going to be able to sell q, because that's all that I have on hand. And the continuous case is the same as the discrete case, with the exception of the summations are now integrals. The last case, though, is what we're going to focus on in this lesson, in this short video. That's the expected unit short. So for the discrete case, let's take a look at it. It's going to be a summation from the x is just greater than my order quantity up to infinity, and it's going to be x minus q, so it's the amount above my order quantity times the probability that that value of x occurs. And I've got the same form over here on the continuous case. What I want you to think about, though, is these are all related. So I can think of my expected units demanded is going to be equal to my expected units sold plus my expected units short. So look at that, look at the terms, and convince yourself that it's true. Expected units demanded is going to be equal of two components. One is the expected units sold plus the expected units that I'm going to be short. So now let's go into the expected units short, and I'm going to explain this through a simple example of a discrete case. So suppose I'm selling freshly baked widgets. We don't know what widgets are, it doesn't matter. Here's the demand distribution. I'll sell between 1 and 8, equal probability for each, so it's 1/8 or 0.125 probability for each. At the end of the day, all the widgets that are not sold are thrown out. So therefore, it's a news vendor problem. It's a single period inventory model. And suppose, based on my critical ratio and all that, I'm going to order 5 units each day. So my Q equals 5. So I'm giving that to you. What we want to figure out is what is my expected demand. Remember that X hat? I want to find my expected units that I'm going to sell, and I want to find my expected units short. So here's our example again. And remember, I have 5 units that I already have. That's my Q. And you can see the probability for each of the other values of X is equal. It's 0.125. And so the first thing I want to find is my expected demand. So what is the average demand? We could probably eyeball the distribution up here and figure out what it's going to be. But essentially all we're going to do, it's a sum product. I'm multiplying this array times this array. So it's going to be the demand value 1 times the probability 0.125 plus 2, the demand, times the probability that I have a demand of 2, 0.125, that's 0.25. 3 times 0.125, and I add those all up, and I get an expected value of 4.5 units. Now this is the expected demand, and note that this doesn't take into account what the value of Q is at all. It doesn't matter. It's the pure demand. But the next thing we want to look at is the expected sales. And we can think of this actually as a conditional expectation. We're finding the expected units sold given that my order quantity is 5, because now it matters. Remember, I have 5 units, so let me just draw a line here. That means up to demand equals to 5, I will sell the amount of the demand. So if demand only 1 unit of demand comes in, I'm going to sell that, right? And if 2 comes in, I'll sell 2. Above 5, though, I'm only going to be able to sell 5. So again, this is just simply going to be the x times the probability of x for the values of the demand up until my q. And then down here, for any value greater than q, it's simply going to be q times the probability of that x value. And so again, I'm going to sum these up, and I get my expected sales, let me clean that up a little bit, is 3.75 units. So with this Q of 5, I expect to sell 3.75 units on average. Now the last thing we want to figure out is expected units short. Again, this is a conditional expectation. It's the expected units short given that I have 5 units on hand. My Q is 5. So all I'm going to do is figure out this loss function. And we use this, call this L sub Q or LQ, and it's equal to the X, the demand, minus the Q, given that my demand is greater than or equal to my Q. So my loss is going to be 0 up until I hit 6 units of demand. Why? Well, if I have 5 units of inventory, I have 5 units hanging out, and I have a demand of 3, will I be short any? No. I have enough to cover it, so I won't have any loss. However, if I have 5 on hand, right, and 6 units of demand come in, then I'm going to be short 1. So my loss function is going to be 6 minus 5, or 1. If 7 units of demand comes in, my loss function is going to be 7 minus 5, or 2. 8 units of demand comes in, 8 minus 5 is 3. I'm going to take each of those losses, multiply it by the probability that it occurs, and I get this, which is simply just the loss, the L sub Q, times the probability of that x, and I'm going to sum that up. So my expected unit short is 0.75. So notice that my expected demand, my x hat, remember, was 4.5. My expected units that I actually sold, right, was equal to 3.75, and my expected unit short, right, this was equal to 0.75. Notice that I didn't need to calculate all 3 because once I have 2, I know the third. 4.5 is equal to 3.75 plus 0.75. The expected demand is equal to the expected units to be sold plus the expected units short. Okay, now we're going to take a case we're going to look at with a normal distribution.